The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, and good evening, everyone. We have made it to the fourth and final webinar of this four-part series, and the final topic that we're going to be giving you today is how you can leverage the special feature of NFC on our LPC800 device. So for those of you who are online, thank you for coming out for the final one. We do have the PowerPoint slides uploaded as a PDF on the right-hand side, and there's, over there's also all the other parts that we had. So feel free to download those, share them. Just like all the other ones, we will have time at the end for questions, and there's a question box on the right-hand side that you can type them in. But that's all from me. So quick intro, but I'll hand it off to Omar now.
Alrighty. Thank you, Ethan. Welcome, everyone. Thank you for joining. As Ethan mentioned, this is the last webinar of this four-part series. Today, here with me, we have Tomás Boda. He's a systems engineer focused on the LPC800 series and also the new MPIs that were coming up in the LPC family. So he has a lot of knowledge. He's going to go over the technical details. Myself, Omar Cruz, I'm a product marketer for the LPC team. I'm going to go over the overview, kind of give you a quick introduction and some wrapping up items towards the end of the presentation. So as we have said, this is the last part. This is the last webinar out of this four-part series. We're going to have new webinars in the upcoming months, but for now, we're wrapping up the LPC800 series. If you want to download the presentation, it's available on your GoToWebinar toolbox. We have the links also. You'll find it in this presentation for the previous calls, the previous trainings. You couldn't attend those trainings, you can do so. You can view what we have recorded. And now we're gonna go and focus on NFC, LPC800, and how to learn or how to leverage this unique feature in your next design. The agenda for today, as I have mentioned, I'm gonna go over an introduction on the LPC family. We're gonna go over to the overview of the LPC800, target applications and use cases. Then I'm gonna hand it over to Tomás. He's gonna go the technical details, talking about the core, the Cortex M0 Plus, memory system, clock, power, interfaces, NFC, which is like the biggest differentiator in the LPC800, antenna design and how important that is for your design. And then we're gonna come back to me to talk about the enablement, what we have ready for you guys out there to leverage, and then the final slide in the summary. If you have any questions, please go ahead and type them on the go. We're gonna revisit them towards the end of the presentation, but you can do that anytime. We're fine with that. Okay, so a quick introduction on the LPC family, and this is a slide that probably you've seen if you saw the previous trainings. These are the 5 pillars of the LPC family. So, of course, innovation is really important. Innovation, innovation, innovation. As a matter of fact, we have the first mass market microcontroller featuring a Cortex M0 Plus along with NFC tagging. So innovation, we are well covered. Ecosystems and partners, those are really important. We know that you guys like to work with different tools, different partners, and we have enabled this not only in the LPC800 devices, but also across the line on NXP, not only LPC, not only Kinetis, but i.MX as well, and other divisions such as digital networking, Layerscape, Core IQ, and such. Supply longevity and quality also important, really, really important. We couldn't stress that anymore. I mean, how important is the quality? Longevity, we're gonna talk over that in this presentation, but that's also a key requirement in the field, and that's also that we have covered in our products. Support network, support infrastructure, that's really important as well. As a matter of fact, we have one of our key members in the support infrastructure of NXP, of an LPC, which is Tomás Boda, coming here, giving the presentation and also answering your questions, as well as myself, from the product marketing perspective. And last but not least, extensive software and tools. We know that just having a silicon is not enough. we have to enable you. We have to have software, tools, development boards. We're going to go over that towards the end of the presentation. And all of these 5 pillars are so important and are helping us a lot in order to accelerate the transition from 8-bit to 32-bit. That's what we are intending to do in the LPC family and the LPC800, to be more specific, bringing low power, high performance FCUs for energy conscious applications. Now I'm going to show you the roadmap. Of course, I'm going to focus in the entry level. Where is my? Yeah. I'm going to focus on the entry level. I'm going to focus on the LPC804 because that's the presentation for today. We already focused on the LPC802 and the LPC804 in the previous trainings. As you may know, these are also Cortex-M0 Plus with different levels of integration, with different capabilities, but we have LPC804 featuring the NFC tag interface. Of course, we have leveraged our portfolio from previous years, LPC804X, which has been really successful, featuring different levels of integration. Of course, if we go a little bit back or earlier, we have the LPC82X, LPC1X. On other ends, in the mainstream and in the advanced, also we're coming up with new products. And as you may know, LPC51U68 was launched 2 weeks ago. It was launched at Computex. LPC51U68 falls under our mainstream end. This is a Cortex-M0 Plus, but we are able to run it all the way up to 100 megahertz. In addition, we have extended and expanded memory resources with 256 kilobytes of flash, 96 kilobytes of SRAM. We are integrating USB in a crystal-less way, so you don't need an external crystal, and also serial connectivity. If we go to the advanced products, of course, we have a lot of history, but we came up with the LPC540XX this year. This is a flashless device. This is a Cortex-M4 based device with USB, both full speed and high speed, LCD, Ethernet, CAN interface for industrial applications, SDRAM, QSPI. Anyway, it is full featured, and the next step that we're going to take towards the end of the year is we're going to bring the same product but with security capabilities, meaning we're going to have SRAM POF, we're going to have encryption and decryption, and a lot of different security capabilities available in the same microcontroller. It's just going to have a spin-off, if you will, with the LPC54S series. This is how the roadmap looks like. I'm going to zoom in on the end value, on the value end, I'm sorry. As I have mentioned, we have leverage on our previous launches on the LPC824, 822, different levels of capabilities. We have taken a cost-efficient approach. We have brought the LPC802, the LPC804, of course, different levels of memory integration. We now have the LPC804, cost-effective with NFC tag integrated into it. On top of that, you're going to see another feature that we're going to talk about during the presentation, but this is how it looks like from a portfolio perspective. If you want a little bit more integration, but you want to stay on the low-end device or low-end families, we have the LPC845, LPC844, different levels of integration, different analog interfaces such as the digital to analog converter, capacitive touch, and such, in different packages. Also, different levels of memories or more memory supported in these devices. Anyway, let's focus now on the LPC804. What's the value proposition? Of course, NFC brings a really key integration into this design, but it's more than NFC tag. Not only we have the NFC tag, but we have integrated a 32-bit ARM Cortex-M0 Plus core. On top of that, we have 3 different levels of memory. We have an integrated flash, we have SRAM, we have E2PROM also available, featuring the ISO compliant NFC tag, ISO 14443A, which can be used for close proximity, easy to use connectivity, an ideal or a really good BLE alternative if you are thinking on close connectivity devices. Because of the low power capabilities of the Cortex-M0 Plus, we are able to bring energy harvesting to power up the MCU. What we mean by this is that we are able to power up the device just by creating just by leveraging on the RF field from in this case, the cell phone. The cell phone is going to be able, or the RF field created in the cell phone is going to be able to power up the device, and we are able to power up the microcontroller itself. Also, this is really important, but we have a small footprint QFN package available for the LPC804. And this is the overview. This is the block diagram of the LPC804. I already mentioned Cortex-M0 Plus ARM core running all the way up to 8 megahertz, 32 kilobytes of flash, 8 kilobytes of SRAM, 4 kilobytes of EEPROM. We have the ISO NFC Type A compliant to the 14443 protocol. Also, I have mentioned the exceptional power efficiency that we bring thanks to the Cortex-M0 Plus. We are less than 900 microamperes running at full speed, running at 8 megahertz in the active mode. We have different power modes, and Tomas is going to go over those in a little more detail. We have serial connectivity, we have I2C, we have SPI, we have up to 12 Gpios. Out of those 12 Gpios are high current drivers and sinks. So that means that you don't require to have an additional driver for these 4 Gpios. Also on the analog front, we have temperature sensor integrated. We have different set of timers. We have the 32-bit, 16-bit C timer as well. Wake up, watchdog timers, or real-time clock counter. Different levels of power supply that are supported from 1.72 all the way up to 3.6 volts. And a temperature range of -40 to 85 Celsius degrees. Everything encompassed in a HVQFN 24 package. One key and something that's really important, and we like to stress this, is the fact that we have product longevity. This means that by the time we launch, this product is going to be available for 10 other years from that moment that we launch. So, for example, in the case of the LPC804, we launched this product on February of 2018. This means that it's going to be available, no questions asked, on 2028. This is a huge leverage for those of you who want to have the consumer products for a long period of time. And of course, we're going to come up with new devices in the next couple of years, but you can rest or you can be assured that we're going to keep this device for another 10 years. On the application side, this is a general embedded. This is a Cortex-M0 Plus that it can be used in different applications. So this is just an example of what we've seen. We've realized that this is a really good product for control panel, for contactless diagnostic, such as thermostats and those kind of products. But the sky is the limit. In any type of application that you want to use NFC and that you need processing abilities, the LPC804 is a product to do so. Another key item, another key capability of this microcontroller is that we support over-the-air features for system firmware updates, and Tomas is going to spend a couple of minutes talking about that. We have OTA for system firmware updates, which means that with your cell phone or whatever you want to use to pair the microcontroller, you're going to be able to do firmware updates over the air, and this can be used in different applications all over the spectrum of the industrial applications, consumer end applications. So we are not limited to these kind of applications. The sky is the limit. Anywhere you need NFC, anywhere you need co-processing or processing abilities with the Cortex-M0 Plus in a really power efficient way with energy harvesting capabilities included, the LPC804 is the way to do it. Now, again, just 2 examples, 2 use cases that we have seen in the field, how we are able to upgrade or update parameters in a camera. In this case, we're able to update them via cell phone. Thanks to the NFC tag, we're able to do processing. We're able to save some of that information thanks to the flash, thanks to the EEPROM. We're able to process that information thanks to the SRAM. Of course, we also have serial connectivity, SPI, I2C. In the programmable LED strip via NFC, you are able to program your lights. If you want different patterns, you are able to program them via your cell phone. Again, using the NFC tag, again, using the processing abilities of the Cortex-M0 Plus. So different kinds of different kinds of applications. And the reason why the LPC800 is important is because we have an NFC tag integrated with a Cortex-M0 Plus, EEPROM, flash memory, and on top of that, and we're going to talk about that in the next couple of slides, but supporting Kyle, supporting IIR, supporting MCU Express as well. Now I'm going to hand it over to Tomas for the technical details. Tomas, are you there?
Yeah, hello everybody. I would like to go through the second part or the technical part of this webinar. I would like to introduce ARM Cortex-M0 M0 Plus. This is a high-performance 32-bit CPU, which has got two-stage pipeline. That is quite good. That the performance efficiency is very well. It's good that it's a single cycle input-output. It has got an wake and wake-up pins, also 2 pins for SVD for debugging with 4 breakpoints and 2 watch points. And there is a vector table relocation if you need it, and it's going under thumb2 instructions. Right now we will go through the memory part. The memory part is divided to 3 parts. The main one, the flash part, which is 32 kilobytes, but keep in mind that only 30 kilobytes can be used. EEPROM, which is connected to NFC also directly, which has got 4 kilobytes, and SRAM part, which is 8 kilobytes. The clocks, there we have 2 main clocks, the system free running oscillator and timer. System free running oscillator is from 62.5 kilohertz to 8 megahertz, and the timer is 32.768 kilohertz, which is good for real-time counter. The system free running oscillator is divided to 3 dividers, which could be divided to different parts of the processor. The main power system, there was an information that it could be powered through NFC. There is an automatic source selector unit and if you don't have a connected battery to a processor, there is a way that if NFC is recognized, it could be powered from a passive NFC, and the processor recognizes that and it goes through this line. The LPC800, it's as I said, power harvesting solution. There is a possibility to go without the battery, but if you are going without the battery, there is a recommendation to add external capacitor to set up I/O port to high, and there you could in turn, or there is possibility that you are able to run also during the Miller pause due to this capacitor, and it's because it's powered from NFC field. Also, there is a possibility to power external device from this power harvesting. You are able to power the external device through a Gpio, preferably high drive pin, which we will talk about later. But keep in mind that energy harvesting is limited to 2 megahertz system clock right now. And what I need to say, very important thing, that energy harvesting capabilities are related to antenna design. So the of power harvesting is how the antenna is implemented and what's the magnetic field strength of the NFC reader. Okay, so right now the low power modes, we have generally four main modes. The active one, sleep, deep sleep, and deep power down. From sleep and deep sleep mode, there is a possibilities to wake up from NFC field, real-time counter, wake up pins from watchdog, or external reset. From deep power down, there is a possibility to wake up from NFC or real-time counter, wake up pins, or external reset. In deep power down mode, all content and registers are not retained, but there is an exception that we have special 5 32-bit general purpose registers in PMU, which could be used to retain some data if you need to go to the deep power down mode. We have also one more mode, which is battery off mode, that you are able to take off the battery and you will wake up from connected NFC field. The GPIOs are a single cycle, which is meaning that we are supporting high frequency toggling. Enhanced GPIO pin manipulating for all 12 GPIOs. All GPIOs could be configured as edge or level sensitive interrupts, and all GPIOs are also programmable for internal pull-up, pull-down resistors, open drain or inputs and repeater mode, and also in the power down modes. We have 4 high drive sources, which could be used as a power source directly for implementation, which is good that it will eliminate external drive controllers and it will save a BOM cost. It's these 4 pins. From other digitals, we have classic timers, one 16-bit timer, one 32-bit timer, one real-time counter, and one SysTick timer. From a communication, we have one I2C and one SPI channel. Debug model, we have used a serial wire debug for debugging, which is using 4 breakpoints and 2 watch points. But also we have implemented GTEC, but it's only for boundary scan testing during manufacturing. The main part of this LPC804 is NFC. So what is NFC? It's same like as RFID, but the reader, e.g. mobile device, provides power, which is the power source. It's initiates RF communication and it captures data from tech. Our NFC solution is compatible with ISO 14443A, part 1 to 3, MyFair EVI, NFC Forum Type 2. It has got easy interfacing with standard user memory space, and it's, as I said, passive operation possible due to power harvesting. The main part of power harvesting is antenna design. So you are able to connect directly your antenna to our processor, but you have to calculate the dimensions of the antenna. There is a recommendation to use class 3 to class 6 antennas, which is the differences in dimensions, and also there is a possibility to connect a capacitor for tuning the antenna design. So what is good to say that antenna size and turn counts has an influence to power harvesting possibilities. So higher turn counts improves energy harvesting output from phones in close couplings or generally the reader. And if you will reduce the turn counts, it will improve the stability of energy harvesting in the distance between reader and tag. Antenna design documentation could be downloaded from nxp.com in LPC804 sheet documentation, and here is NTAC antenna design guide, which contain some antenna design guide where is a calculation how it could be implemented. Also some references class 4, 5, 6 antennas and Excel sheet where you could calculate your dimensions, which you have to be known. The last part of this one is OTA. We have implemented an encrypted over there firmware update over NFC. Just keep in mind that LPC804 have to be with the boot ROM version greater than equal to 0.14. And OTA doesn't work with energy harvesting. It have to be battery powered or USB powered or something like that one. OTA firmware is using secondary bootloader. How it's working? The secondary bootloader, which is in 8 and 04, download encrypted firmware over NFC from communication from a reader. It will decrypt the downloaded file and update the whole flash memory with the new firmware. We have prepared Android application example, so you can download it from Google Store. It's LPC804 NFC demo, and you are also able to download the second part, the OTA firmware, which is where is the example is on our website nxp.com in a part 8N04, where you are able to download secure image creator, also sample binaries and source code. The OTA documentation is in a sheet also documentation, and LPC804 encrypted over the air firmware update using NFC. Right now, I would like to give an voice to Omar. Thank you very much.
Thank you, Tomas. Sorry about that. We were having some technical difficulties. So thank you, Tomas. That's a really good presentation of technical details. When people come to me, they usually ask me, okay, so I mean, that sounds really good. What is it out there for us? How can we start our design? What do you have? And this is what I'm gonna present for the next couple of slides, the enablement side. So first of all, we have an LPC804 MCU development board. It's a low-cost demo board, development board where you can start your prototype. Pretty much, we have the LPC804 HVQFN package available here. We also have a detachable debug interface that you can see on your left screen. Oh, not a left screen, on the left side of the board here, showing it here. We also have a 10-pin SWT connector for optional external debug, so plenty of debug interfaces. We also have expansion headers. We have a 5x7 LED matrix debug for debug and demo. So this comes with a pre-programmed demo, and you're gonna see it that as soon as you pair it with your cell phone, a message is gonna scroll here, and it's gonna also be scrolling in your cell phone in case you wanna use our pre-programmed demonstration. We have an integrated NFC antenna. We have buzzers. We have an option or two different options for coin cell batteries. So depending on the size of the battery that you want, either battery can power up the whole development board. Also, you can use USB if you want to power up. That's perfectly fine. It's up to you. And something that is not mentioned here, but it's really important. We have come up with the pre-programmed demo, and the app is already available at your Google Store. So if you come up with the demo, you can go to the Google Store, type LPC800. You're going to find an app that's going to be like your first stop. If you want to use MCU Expresso IDE, it's fully supported. If you want to use IAR, if you want to use Kyle, they're also supported. We have a board support package, and I'm going to talk about that in the next slide. We have board support packages for MCU Expresso IDE and also for Kyle and IAR. If you want to know how to get started, we have videos. We have step-by-step guidelines on how to do so, how to plug it in, how to install the drivers for the debug interface, how to get the software. Where in nxp.com can you find that software? How can you import that board support package, use it, whether it's in MCU Expresso or whether on Kyle on IAR, how to use it, how to import that, how to build, and how to run it. The board support package, you're gonna find examples. You're gonna find ways on how to start leveraging this LPC804 board, how to start leveraging the LPC804 and the NFC and the Cortex M0 Plus. So we have you covered on those kind of things. A little bit more on the board support package, where you can find it. You can go to the demo board webpage, and you're gonna see it under software and tools. And you're gonna see whether you want to use MCU Expresso, whether you want to use Kyle and IAR. You download it, and you're gonna find these folders, and it's just a matter of importing those folders, whether you want to use the MCU Expresso or the Kyle IAR, as I mentioned. If you want to know how to do it, you can follow the step-by-step guidelines that we have on nxp.com/LPC804 or the LPC. I'll show you the link for the demo board where we have all these guidelines. Last time that I came here, 3 weeks ago, someone asked me about the MCU Expresso. Was it free? That's when I kind of wanted to implement this slide on this presentation, because the MCU Expresso is free, full feature, unlimited code size. You can use it not only for the LPC devices, you can also leverage it for Kinetis and i.MXRT. So across the microcontroller line, here on nxp.com, on NXP, you can use it. If you're familiar to Eclipse or GCC-based IDEs, that's perfect, because this is based on that. It's application development with the Eclipse and the GCC-based IDE for advanced editing, compiling, and debugging. We are supporting the LPC tools, the Tower tools, the Freedom, whatever we come up in the development board section is going to be fully supporting the MCU Expresso IDE. And this is how it looks like. It's really easy to use if you have experience on debugging, if you have experience on compiling. Really easy to use. If you find any difficulties, of course, you can go to the webpage and learn more about it. Not only we have the development board, not only we have the software on terms of a board support package, not only we have examples and we have the MyMCU Expresso IDE, we also have a reference design. If you want to take a look on how it would look like in an application. This is something that we built here on NXP. This is a buttonless IoT node reference design. We're in a single chip solution. I mean, we have the case here, but it's pretty much just the LPC804 with LEDs and with LCD, with a small LCD screen, OLED LCD control screen. Leveraging on the different features of the LPC804, of course, NFC 14443 Type A, we leverage on that mainly. ES2 for temperature data log storage. Because of the temperature sensor available in the LPC804, we also took it and put it on our Android app, and we were able to see the temperature. We have an integrated RTC4 clock. So in this screen, we show the actual time and date thanks to the RTC. We have, as I mentioned, a high accurate temperature sensor. We have timers. Whenever you want to set up an alarm, you can do that. And this is gonna sound. It's gonna emit a sound, like an alarm will do. We have, of course, the Gpios for LED control, and this can last a lot of time. This is battery coin cell operated, but the low power modes available on the LPC800 make it last for a really, really long time. So this is just a type of applications. This is just a demonstration that we wanted to show you. A reference design. We have also uploaded the Android app that we use for this reference design. We have also hardware schematics. If you want to take that as a leverage, you can do that. You can go to the webpage of this reference design and learn more. We also have videos. We have around 3 videos talking about this reference design. We have also videos on the development board. So we have a lot of content available in nxp.com. Of course, if you want to know more, if you have any questions, our community is the ideal place to take a look at. Take a look at and of course ask your questions. In summary, and we have explained the main features of the LPC800. We feature an unique integration. We have the Cortex M0 Plus with a really good power efficiency, and on top of that, we have the NFC tag. We also have the timers that you usually find in the LPC devices. We have a real-time clock counter, temperature sensor, Gpios, SPIs, I2Cs. So it's a really, really, really well-integrated single-chip solution. Thanks to the Cortex M0 Plus, we have a really good power efficiency, 4 different power modes integrated into the LPC804. We are able to do energy harvesting thanks to this power efficiency. So we're able to power up the device without the necessity of having a coin cell battery or having a USB attached to it. So that's also a big plus because of the power efficiency features available in the LPC804. And as I have mentioned in these last slides, the ease of using the enablement and tools. We have board support packages. We have reference designs to start the design right away. We are supported by not only the MCU Expresso ID, but also by Kyle, by IAR. We have the low-cost development board, so everything is all set for you guys to take a look at, get your development board, and get started right away. We have get started videos, and we have a lot of videos also if you want to know more. If you come up with any questions, of course, the community webpage is really important to us. I keep track of not all the questions, but I cannot sense what's coming into the community to keep myself updated. And of course, not only Tomas, but the team is behind the infrastructure of the support, and it's really important for us. If you want to know more about the LPC804, please visit our webpage. This is the webpage. If you want to order a board, if you want to know more about the board itself, this is the webpage to do so. If you want to know about the reference design that I've talked to you about, want to know what kind of applications you want to see a video of it, this is the webpage to do so. And also, if you want to know more information from the technical side, we have reference manuals, data sheets. Tomas already talked about the NFC antenna design that is also available in the LPC804 webpage. We have the OTA firmware update using NFC. We have a technical note on that. We have the antenna design. We have testing codes and examples for whether it is Kyle IR or MCU Expresso. We also have the printed circuit boards if you want to know about the schematics, not only for the reference design, but for the development board itself. So we have plenty of tools, plenty of information, videos. Of course, you can reference this presentation that is also going to be available on nxp.com. So everything to get started right away. And thank you, everybody, for joining the call. If you have any questions, this is the time to type them. If we don't receive any questions, we're gonna wrap up the call and finish the call. But anyway, thank you, everybody, for attending this presentation.
Thanks, Omar. Hold on, let me see what questions we have.
Yeah.
So, does NXP make the Android application source code available to help customers with that side? with that side of things.
Yeah, I got the question. So yes, you're gonna find the Android app source code for the reference design. We are working on getting it uploaded for the development board as well. We're working on it. I think our web team is by now working on try to have it up. If it's not up yet, it's gonna be up in the next couple of days. So yeah, well, you can take that as a example on how to build your own application.
Okay. Okay. So if anyone has any other questions, we can, I think, again, I know Omar has stressed this throughout the webinars, but there is we do have the LPC community site where you can ask questions. We're very active on there, very engaged, so we will get to your questions if you ask them on there.
There's another question.
Oh, actually, we do have another question. Do you support Visual GDB for development?
Yeah, the answer to that is no. We don't support Visual GDB. Right now, what we support for the LPC800 in specific is the ID, MCU Express ID interface or tool, and the Kyle and IAR. Yeah, Visual GDB is not supported at the moment.
Awesome. Thanks, Omar. Just waiting to see if there's any more questions coming in. We do have a bit of time.
Okay. Yeah. Where do you find the, I'm guessing IAR demos? Those can be found in the development board website. So under the software and tools, you can find the code, the board support package, and you're gonna find examples of demos that we have available for the LPC804.
Okay. Well, I think that's. Oh well, they just keep coming in. Okay, so why isn't the LPC804 SDK integrated into the MCU Expresso SDK builder versus a download of the SDK?
Yes, that's a good question. So we came up with the board support package for the LPC804, and this is a little bit of history. So the LPC800 had their own code bundles and code examples applications. For the LPC804, the architecture is a little bit different. So we haven't put it on the SDK. We are working, and we might provide news in the future about the LPC804. But that's exactly right. We don't have it available on the SDK at the moment. We're working towards it, and hopefully we're going to find it available in the future. But today we find it really well as a well-structured piece of code, the board support package, because it's especially done for the LPC804. And yes, while it is not available in the SDK because of some limitations in the architecture, we are finding, or we're trying to find a way to implement it on the SDK. But for now, we want to make it, or we have the board support package that was specifically done for the LPC804, and we can integrate it in the MCU Express ID. On the terms of the SDK, we are finding, or we are trying to find a way to implement it. It's not at the moment, and it's not a definite answer whether it's going to be or not. But we are trying to find ways to do that.
All right. All right. So any other questions, you can direct those to the community. But one more thank you to everyone who's joined. Again, we will send out a follow-up email either today or tomorrow So keep a lookout for that, and feel free to share this around with people who weren't able to attend. Want to get the word out. But thanks, everyone, for watching, and we will see you later. Bye.
See you. Bye-bye.